Good evening and welcome to this special asset colloquium and Vigyan Vidushi special lecture jointly organized. Asset, as some of you know, is the stands for Advances in Science, Engineering and Technology. This is a weekly colloquium series, and Vigyan Vidushi is the TIFR summer school program, specially made for women students who are completing the MSc first year. As a part of this summer school, we are running this special lecture series to acquaint them for the work done by eminent women scientists. And today we have a fourth lecture of this year. We also have several people online, and warm welcome to all of them. It's indeed a pleasure to introduce today's speaker, Dr. Priyadarshini Karve. Priyadarshini completed her PhD in physics from University of Pune in 1998, and she actually has a connection to TIFR because she did some of the experiments at TIFR, maybe a small part, but she did. So in a career spanning nearly 25 years, Dr. Karve has invented a number of improved biomass burning cooking devices and decentralized organic waste to fuel technologies. She developed a methodology for technology selection and promotion to improve adoption of clean cooking energy devices by end users. In the past 5 years or so, her work has focused on devising and promoting strategies for low carbon sustainable urbanization. So as you'll see, you will look at somebody who has got a physics PhD and worked out in a completely different aspect, will hear that. I must add, Dr. Priyadarshini Karve has apart from her own achievements, has a really very relevant family history related to the both women education and a social reformer. Her great grandfather, Dr. Maharshi Karve, was a social reformer and worked for widows education. He founded the first women's university SNTT in the country, some of you know. Her grandmother, Iravati Karve, was an anthropologist and first sociologist in India, and Government of India have honored her by announcing a chair in her honor. Dr. Priyadarshini Karve, in her own right, has many credentials. Last year, as a part of, or rather in the current year, as a part of Azadi Ka Amrit Mahotsav, the Government of India has released a list of 75 prominent young scientists, and she features among them. She has several research papers in peer-reviewed journals and contributed to technical books. She is actively involved in national and international organizations working on decentralized renewable energy, sustainable development, climate resilience, etc. Her work has been honored by several national and international awards and has been featured in a number of national and international periodicals, publications. She is very actively involved in the radio and TV programs, particularly promoting the sustainability and this alternate energy sources. So I now request Dr. Priyadarshini to give a comment.
Thank you very much for the introduction. I have also been asked to talk a bit. There's some echo coming. Yeah. I have also been asked to talk a bit about my journey. So I think I'll start with that because that also leads into the topic that I'm going to talk about. Because that is sort of the learning which led me to some conclusions is part of that journey. So I grew up in a small town, which is an agricultural area. And every day I was watching, it was a sugarcane growing area, and I was watching sugarcane trash, which is the waste that is left behind once the cane is harvested. That is just burnt off in open air. There is no other use for it. So I sort of grew up watching that, and that made me think that maybe this can be converted into some kind of a fuel. So that was one of the triggers. When I was studying for my bachelor's degree in Pune, Ferguson College, for the third year project, Being a relatively laid back and lazy person, I didn't want to go and work in some unknown environment. At that time, my father was leading a research group in Pune. And the only thing in that work, which was close or remotely, I should say, related to physics, was this work that was going on improved Cookstoves. This was part of a government program. It was called National Program on Improved Cookstoves, and this group had a mandate to design smokeless stoves for Maharashtra and Goa states. So since there was that little bit of a connection with physics, I thought I'd do my project there. That will be an easy thing to do. So I spent 3 or 4 months working in that lab. That work was related to trying to come up with a standardized fuel using locally available materials for a particular improved cook stove design. But in those 3 or 4 months, I myself inhaled so much smoke that it made me realize how difficult it must be for rural women who are day in and day out cooking on smoky cook stoves. So at that point, I felt that this is an area where physics can help ease the problems that women are facing, especially in rural areas. I was also fascinated by the scientific challenge of designing an improved cook stove, because if you think about it, the fuels are varied, but the device has to perform the same function. So designing a good cook stove is actually scientifically more challenging than designing a car engine or even a rocket engine, where your fuel is standardized. Whereas here you have to design a device which will give the same output, but will sometimes use firewood, sometimes agricultural waste, sometimes cow dung cakes, wide variety of fuels. So that scientific challenge was also something which fascinated me. So in master's degree program, I thought I should do some work in this area. And with that intention, I did a specialization in energy studies, which was a bit disappointing because it only dealt with solar energy. And when I started looking for opportunities for doing PhD in physics, I thought I can do some work in biomass energy for households. Not a single physics department in India was working in this field. I mean, a device which is used in 70–80% households, but no research happening in the country on that device. So my PhD is in an entirely different area, which in a way was a blessing in disguise, because the more things you look at and are exposed to, you will have that different perspective coming in. So I worked in material science. My PhD was on diamond thin films, and some of the Raman spectroscopy work was done here at TIFR. So I have some very fond memories of visiting here. So it's great to be back here after 25 years almost. So anyway, I completed PhD, but this field kept on sort of pulling me in. So at that time, my father and his colleagues, they had just established a new organization, an NGO, which was focused on research for rural development. And they wanted research projects to be submitted, and very few people in that group, I was also one of them, very few of us actually had the qualifications to submit research projects. So I was sort of pushed to do that. And my very first project was under Department of Science and Technology's Young Scientist Scheme. It was to convert agricultural waste into charcoal. And from that project, we also developed a steam cooker which works on this charcoal. And I'll talk a bit about that as we go on. This entire work went on to win the Ashden Award in 2002, which is an international award in the field of renewable energy. And it was the first time that that award was won by somebody in India. Now there is a bunch of people who have won this award, and they have established an organization called Ashden India Collective. But we were the first ones who brought this award to India. After that, I got a job, and for 5 years, I was full time in teaching. But side by side, I was involved in some of the research work and promotion work going on around improved Cookstoves. Around this time, the government program for improved Cookstoves stopped, and we had to, at the organizational level, figure out how to pay salaries to all the people who were employed under it. So I applied for an international funding opportunity, which we got, but that was a slightly challenging task because it focused on commercializing these devices. So we were supposed to create entrepreneurs who would make these smokeless cooking energy devices and promote them or sell them in rural areas. So we took on that task. We worked across Maharashtra state with nearly 10 different NGOs. We managed to set up about 100 different enterprises across the state. And then problems started creeping up because people were not willing to buy. So far, for so many years, they were getting free cook stoves. So suddenly somebody comes and starts selling the same thing, they were not interested in buying. Another thing is an aspirational aspect, that if I have to shell out a few hundred rupees, I might as well go and buy an LPG stove. Why should I buy another wood burning stove? That was also a response that we were getting. In the process of, like, in order to hold all these small enterprises together, as a part of that project, we had created a company called Samuchit Enviro, and I was looking after that company in that process. I had left my job in the meanwhile. It so turned out that slowly these businesses started failing, and we also were failing in a way. But while we were struggling to sell in rural areas, urban people were approaching us out of romanticism, environmentalism, wanting to use these devices. So some sales started happening there, and my focus sort of shifted to what is going on in the urban sector. We also expanded our activities. In the meanwhile, I had started teaching as a visiting faculty in a liberal arts program where I designed a course around climate change and sustainability. Developed a carbon footprint calculator, personal carbon footprint calculator, and we started doing workshops around that to inform urban people about their contribution to climate change. Because in India, we always hide behind the national statistics. But if you separate out the data of rural and urban people, urban Indians are also contributing to the problem of climate change. So that was the message that we wanted to give. That got me interested in all the urban sustainability issues, and last few years I have been focused more on that. The overall thing that I see is sustainability is about systemic change, societal change, change on the individual level, but it has to start in urban areas, because rural populations look up to urban populations as a aspiration or as a their ideal. So if change happens in the urban system, then it starts reflecting in rural systems. We also had a similar experience that once our rural work stopped and we started selling cook stoves in urban areas, our demand from rural areas went up because people were seeing those devices in their urban relatives' households. So this was also an interesting phenomenon that came up. So that has been the journey so far. I mean, I started off with a certain scientific goal in mind. In the process, I realized that in this whole process of developing cook stoves, trying to sell them to women, I also realized what great misconceptions I had when I started on this journey. And some of those I'll be sharing with all of you. It has sort of shaped an entirely different viewpoint, which I'm going to talk about. And I hope that you guys will also agree with me. But apart from that, this whole work around climate change issues and all has created some other areas in which I'm working. The teaching part also has gone in various interesting areas. As I teach in a liberal arts program, it has been more of an interdisciplinary or multidisciplinary focus. From an applied scientist, I went on to become a sort of a reluctant entrepreneur. I mean, once the company was established, I had to run it. So that is what I'm doing. But then I got involved in other areas, other organizations, other companies. And this is where I am right now. I am today going to talk about sort of drawing on the work of three organizations that I am associated with. One is Samuchit Enviro, which is my own proprietary firm. Another one is Urja Box, which is started by a young, another woman entrepreneur in Pune, which has a very interesting business model, which I'll talk about towards the end. And I'm a partner in that. And Cleaner Cooking Coalition, which is an international group working in the developing world with a totally different take on the cooking energy sector. The name Cleaner Cooking Coalition, that also I'll explain in the end. So, with that, let's talk about what I want to say, that we can think about protecting health as well as climate from the cook stove or cooking energy device that is used in kitchens. So, yeah, okay. Okay, so let's look at some numbers, and this is typically the starting point of any discussion on any energy access related talk. That there are about, at this point in time, 770 million people who still lack access to electricity, and 2.6 billion people who are still cooking on so-called polluted fuels. Let's look at another angle of this data. This also means that there are about 1.8 billion people who have access to electricity, but they haven't shifted to cooking on electricity. They continue to cook on these so-called polluting fuels. Why is that? So we will see the answer to this question also in a few minutes. Another piece of data is that this is a projection that use of polluting fuels will keep on increasing, especially in Asia and Africa, till 2050 at least. Now, what do you mean by polluting fuels? So typically, polluting fuels mean solid biomass fuels, that is firewood, charcoal, and so on, and traditional cook stoves. So that combination. Often this also includes kerosene and kerosene wick stoves. Those are also found to be quite polluting. And this data, as well as the projection, comes from International Energy Agency. So this is the background. Now, it's important to also understand what do we mean by energy access, because these numbers are related to that definition. Because if you think about it, when we say 2.6 billion people do not have access to clean cooking, they are still cooking. That means they do have access to some energy for cooking. It's not clean, but it's not total lack of access. They are not eating raw food. Right? So in this context, it's important to understand that energy access typically means this, that it is access to those energy sources where accessing that energy service is not harming the health of the user. Okay, so the clean aspect is sort of hidden in that definition of energy access. Somebody may be having a kerosene lamp in the house, but that is not considered access to lighting energy. If you have electric bulb, that is considered access to lighting energy because that is not harming the user health wise. So that is how these numbers come, that it is access to that energy which is non-polluting, which is not impacting health. What if we further added on to this and said that let's define energy access as access to those energy services that are non-polluting and climate friendly? It is actually perfectly logical to change this definition in this way because of the climate crisis that we are facing today. If we want to address the climate crisis, our energy systems need to transform, and therefore we have to relook at the definition of energy access and bring in this another condition on the energy that we want to create access for. But the problem is, if we define energy access in this way, then all 8 billion people have no energy access. Because think about the energy that we are using. It is electricity mostly made from burning coal, and it is petroleum fuels, none of which is climate friendly. So if we add this another condition, then none of us have access to energy. And if we say that, then that raises some more uncomfortable questions as what have we achieved so far then? What does all this so-called development mean? So it's a sort of a rabbit hole of uncomfortable questions. So diplomatically, it is inconvenient to define energy access in this way. And that is why the focus remains only on the health aspect. Nobody talks about climate change. But we are not politicians here, we are scientists. So we can stick to something that makes logical sense. So let us keep this definition of energy access in mind. And keeping that in mind, we will not talk about electricity, but we will focus on cooking energy. Let's look at the spectrum of cooking energy technologies that we have today in the world. At one end of the spectrum, you have the traditional cook stove with traditional fuels. In this case, what are the climate impacts? What are the health impacts? Health impacts pretty straightforward. There is research available from across the world which clearly indicates that use of traditional fuel and traditional stove combination is polluting. It is creating harmful health impacts for women and children because across the world, it is typically women who are in charge of cooking and children spend more time with their mothers. But interestingly, you can also solve this problem without touching the cook stove at all in many cases, not all cases, but in many cases, you just improve the ventilation in the house and that will reduce exposure to harmful emissions for the cooks and the children. What about climate change? It depends. There is a context to it. If you are cutting down forests to harvest fuel to cook, then that is unsustainable and that is also harmful from climate perspective. But most of the domestic rural cooking uses fuels that are sustainably harvested. These are typically agricultural waste or waste from forestry or waste from deforestation due to other compulsions. So if you look at the life cycle of the fuel that is being used, often it is carbon neutral. But of course, when you use that fuel in a badly designed stove, you do get what is called as black carbon, or we are more familiar with it as the term particulate matter. You look at the air pollution data, it talks about PM2, 2.5 or PM10. That is also called black carbon. Those are the black carbon particles which we see as smoke, which comes from wood fires. So black carbon is a greenhouse. It's not a gas, but it's an element which also produces greenhouse effect. And if the burning is not happening properly, some methane generation also can take place. So there is a possibility definitely of biomass fuels used in this fashion contributing to climate change. So that's the situation as far as traditional cooking technologies are concerned. If we go to the other end of the spectrum, which is what is there, I think, in almost everybody's kitchens in this room, which is either an LPG or a piped natural gas cook stove and electric cooking energy appliances. In this case, the energy sources are definitely contributing to climate change. They are all fossil energy based. Health wise, there is again a lot of data present which shows that these are clean burning fuels. The stoves are designed for those fuels and there is no pollution as such. So that has been the understanding for a long time. So this also will tell you why the focus on health in the energy access definition has led the entire cooking energy sector to push for shifting away from wood burning stoves towards LPG, electricity, and so on. Even in India, we have the Ujjwala program, which has given now LPG connection to almost every household, which is a good thing. But there are some issues associated with that, and we'll talk about that in a minute. So this is also very much logical. Why everyone is saying that let us shift people away from wood burning stoves and towards LPG, PNG, electricity. But if you think about the future, there is a bit of a problem here. Firstly, what is happening is from the perspective of health impacts, as the technology for measuring air pollution has also been improving over time. So now some research papers have appeared which claim that there is indoor air pollution happening from LPG and PNG stoves also. So the health aspect is now questionable for these stoves, and therefore some people are saying forget about everything else. Let us just focus on creating electricity access and let's shift everybody to cook with electricity. So that is also, there is a logic to that argument. But if we think about what is going to happen to fossil fuel supply chains as we move forward in this climate crisis scenario, and already some of the things that are happening around us are giving an indication that the prices are going up because the supplies are becoming uncertain for a variety of reasons, political reasons as well as climate related reasons. But as we go ahead, the overall trend is that the petroleum industries are saying that, okay, coal is polluting, let's phase it out. Liquid petroleum fuels are polluting, let's phase them out. But natural gas is the least polluting of all fossil fuels, so let's stick with that, which means that more and more sectors will use natural gas. So how much natural gas will then be available for the domestic cooking energy sector, from which there is a you cannot increase the price beyond a certain level. You can't make profits out of people's domestic kitchens. LPG is a byproduct of petroleum refining. So if we are moving away from petrol and diesel, what happens to the supply chain of LPG? So these are the issues that are going to come up in the next few decades. So this means that we cannot say that, okay, everybody shifted to electricity and LPG in the kitchen and now that's the end of that energy ladder. We have achieved a goal and now everything will be fine. That's just not going to work out like that. Firstly, you are not solving the climate change issue. On the other hand, the supply chains are going to be disrupted as solutions to climate change start coming in place in other sectors. So these problems are there. And it seems that as far as petroleum fuels are concerned, even the health goal is not getting achieved anyway. And there is a third aspect of it. And here is also partly the answer as to why a large number of people, in spite of getting access to electricity, haven't shifted to cooking on electricity. This is the data I'm presenting here comes from the work of a colleague in Cleaner Cooking Coalition, Professor Macera. His work is in Mexico. And you can see here that this big circle is for traditional fire. So traditional cook stoves are not doing only cooking. They are serving many other thermal energy functions in the kitchen. And this was my biggest learning when I actually started working in this sector. As a physicist, when you design an energy efficient cook stove, how do you define efficiency? It is energy output versus energy divided by energy input. Energy input is calorific value of the fuel multiplied by weight of the fuel, mass of the fuel that is going in, right? But what about the energy output? So to do this calculation, we only think about the energy that is going in the cooking pot. So the typical method that is used is you take some X liters of water, measure its temperature, bring it to boil, and that will give you how much energy has gone into that water. So that is the energy output. The energy that goes into heating a mud stove is considered as a wasted heat here. But what is actually happening in the kitchen? In the kitchen, after the cooking is done, the cooking pots are still left on the stove. Why? Because the stove is slowly radiating heat that keeps the food warm, and it's also a way of preserving food. In these coastal areas, you will find that salt is stored near the cook stove because that is what keeps the moisture out. In Himalayan regions, the heat being radiated by the stove is heating the space, heating the house. So calling this as wasted heat is wrong. It is serving some purpose in the household. As scientists, we never took that into consideration. And we sort of declare that these traditional stoves are energy inefficient. So this is just one example. You will also find that the same stove is used for some other purposes, for drying of wood for next day, or for heating water for bath. So it is not just a cook stove. It is doing many other things. And when you design an energy efficient stove and replace the traditional stove with it, it is designed only to do cooking. And that is what you can see here. This Patsari stove is an improved cook stove. But it doesn't do everything that the traditional stove has been doing. It can only do some of the functions. That means that household will continue to use traditional stove even when they have acquired an improved stove. Look at LPG. LPG is so efficiently designed for cooking that it doesn't do many of the functions that a traditional stove does. Which means that even if that house acquires LPG, it will continue to use traditional stove for those other functions. And if you have a traditional stove operating in the kitchen, it is negating all the health benefits that the LPG stove is giving you. So just by creating LPG connections, you are not going to solve this problem. So what is happening in our kitchens? How come we have shifted to 100% LPG or PNG or electricity? We are not using traditional stoves, and all the thermal energy functions are needed in our houses in cities also. So you have to realize that typically those houses which have shifted to exclusive use of these modern fuels also have acquired many other appliances. We have a refrigerator, so we don't need to use the heat of the stove to preserve our food. We have other food warmers. We have separate devices for water heating. If space heating is required, we have separate devices for that. So we haven't really exclusively shifted to an LPG burner. We have shifted to all this range of appliances to shift away from traditional cook stove. So one important big learning that I had was that you cannot have a single technology solution that will solve this problem, because there will always be something that we call in our I'm trying to oops okay, so what we call stove stacking. Okay, stove stacking means multiple cooking energy technologies being used in the same kitchen at the same time for doing multiple functions, for performing multiple functions. And every demographic group, this is based on the work, the data that we collected, every demographic group has stove stacking. Think about your own household kitchen. You are using LPG, but you are also using electricity. Many people have now started getting piped natural gas. They are still not giving up their LPG stove. And we have solar water heaters now, which have become very common. So if we think about all the thermal energy services that we use in our house, we are using multiple devices and multiple energy sources. Same is true with a rural household. Here, the fuel stacking is happening because new technologies are coming in. If people can afford them, or a government scheme gives them that connection, they will take an LPG connection. The LPG cylinder will be there, but it will be used very sparingly. But from the other side, what happens is this household has an LPG connection. So it is assumed that all their cooking is happening on LPG, and therefore the house doesn't anymore have a health problem, which in reality is not the case. We found that family size may be 10 people and one LPG cylinder lasts for 6 months. So obviously it is being used only for making chai pan. The main cooking is still happening on the traditional cook stove. So possession of a device doesn't necessarily mean that it is being used. So how do we then look at this stacking issue? Do we try to figure out, do we try to find a single technology solution that can replace the entire stack? Do even such technologies exist? So we need to remember, by our definition of energy access, we need to address health, we need to address climate change, but we also need to ensure that what the user needs gets done by that stove, otherwise it's not going to get used. And if it is not used, it's not going to fulfill the health and climate requirements also. So now there are 3 conditions for cooking energy devices to fulfill. They have to provide the services that the user needs, and they have to be reasonably good for health as well as climate. There is no single cooking energy technology which satisfies all these requirements. I'm going to show you some technologies which meet both health and climate requirements and some of the user needs, all 3 sort of partially. And some of these are coming from my own work. So if you look at the first picture here, this is a very, very basic improved biomass burning cook stove. It's not very clearly visible here, but if you see the corner here near the lady, this is where there is a chimney of that stove. So smoke, whatever little smoke is generated, is being taken out of the house. And this is a 2-pot stove which is designed to generate less smoke in the first place. The combustion is better. So this is one technology which is low polluting. It's not no pollution, but it is low pollution. But it is fairly close to the traditional cook stove and therefore does most of the functions of the traditional cook stove. And because the fuel requirement is less, the chances that sustainably harvested fuel will be used in it are higher. So partially it meets the health agenda, climate agenda, and it is a decent enough stove that many families have actually given up their traditional stove and shifted to this kind of stove design. What you see next to that is a portable stove, which is based on the similar principles. It has a metallic body, but inside there is a insulating material that is put there, which prevents a lot of heat from escaping. So this is more for migrant people or for urban poor who are not necessarily living in one location. Or their houses are too small and cooking is happening outside. So there are a number of places where portable stoves are preferred. What you see down below is the charcoal fueled steam cooker that I was talking about. The design has evolved over the years. This uses about 100 grams of charcoal to cook dal, rice, and some vegetable for 4 to 5 people. And to make that charcoal, we have designed this kiln, which we call trash flasher. You can take any type of agricultural waste, your garden waste, forestry waste, and convert it into charcoal here. So what is happening is the biomass is getting heated. There is very little air that is going in. So only one layer burns. Rest of the biomass gets heated. Volatiles are driven out. And that is the gas that is burning up there. The moment the volatiles come in contact with air, they start burning. So you are burning off the pollution essentially. And because inside hardly any air is going, the inner material doesn't burn, there is no oxygen. So it just chars. Once the flame stops, that means all the volatiles have come out. You can stop the fire and you get char. If it is dry leaves or grass, etc., you will get char powder. If you are using things like coconut shells or bamboo waste or things like that, you will get charcoal, lump charcoal, similar to what you see in the market. But it is made from waste biomass and therefore we call it renewable charcoal. So this renewable charcoal, about 100 grams per meal is what you need to cook dal, rice, vegetables. You can, anything that can be cooked by steaming or boiling can be made in this. So even idlis, dokla, biryani cooks very nicely. So steamed and boiled foods, people actually enjoy this because slow cooking at low temperature means all the taste is retained, all the nutritional value is retained. So some people are using it for that reason also. And this is actually more popular in urban areas, and you can see it is stainless steel, so it fits in a modern kitchen also. This is another stove which is a charcoal making stove. It's a natural draft gasifier, where in this case you are just burning off the volatiles. Here you use the heat of the burning volatiles to cook, and you can harvest charcoal from this. So we call this a Sampada gasifier stove because it's like your fast breeder reactor. It gives you energy from one type of fuel and produces another type of fuel, which you can use in another cooking energy device. So these are, this sort of gives you a glimpse of the work that I have done in this sector. But there are other technologies also available. So the other company that I mentioned, Urja Box, has been promoting a variety of solar cookers. These are designed by various people. I'm sure you are familiar with the box type solar cooker, but now there are many other designs which are more user friendly and easy to use even for household cooking. So there is a range of solar cookers. In the case of solar cookers, it is definitely a big positive for climate. a big positive for health, no pollution at all. And the combination of solar cookers can do most of the things that the user wants. So it still has some way to go as far as meeting all the user needs are concerned, but it's a very promising technology. Another very promising technology where again the group that I was associated with has pioneered the basic technology here, converting food waste into biogas. You may have heard about biogas based on fecal matter, on dung, cattle dung, which is a technology suitable for rural areas. But this is an urban biogas system because it takes care of the organic waste problem. In your own house, your own kitchen waste can be used for generating biogas for use in your own kitchen. It's a fairly small system. You can see here. This is also another young entrepreneur in Pune who has taken this basic technology and made it into a very, very user-friendly process. So the biogas generation happens in these tanks, and the gas is stored in this balloon. So it's a very clean system. There is no smell or no kachra outside. The gas is connected to the stove in the kitchen. So this is also good for climate. It is solving the waste problem, and it is producing a clean burning fuel. So health-wise, this is fine. And it will work exactly the same way as an LPG or a PNG stove. So everything that stove does can be done with this system. Many people in cities are looking for alternatives to LPG, PNG because they know these are fossil fuels. So they are shifting to these type of devices. But as I said, none of these devices are ticking all the boxes totally. So what we are therefore thinking is that let us embrace this whole idea of stove stacking, but let us create a stack that collectively will meet the health goal, the climate goal, and the user need goal. So how do we sort of visualize this? For rural kitchens, it can be locally produced processed biomass fuels from their own or neighborhood agricultural waste, garden waste, and so on, with the correspondingly designed cook stoves. I mean, if you have some kind of a standardization even for solid fuels and design a stove which is meant for those fuels, you will get better efficiencies and less pollution. So that's the idea there. And in some locations, solar cooking will work even in rural context. And you think about LPG and electricity as something to fall back on. So primary level cooking energy devices are all renewable energy driven. But you still have an LPG connection, you still have some electric appliance, which will be the fallback option. Similarly, in urban context, you have these technologies like the urban biogas system, which will solve both the problems. Your organic waste is taken care of and you get energy. So those kind of processed biomass fuels, charcoal also from your garden waste. So you can use this combination of biogas and the steam cooker. There are some very fancy, expensive solar cookers which do a lot of interesting stuff, which are affordable for urban households. So people can go in for that. There are induction stoves which are powered by battery, which is charged by solar PV. All sorts of stuff is now happening. There was a recent announcement of a stove, a solar powered stove coming from, I think, Indian Oil. I haven't seen it in action, but some interesting stuff is happening around solar stove. But the price of that stove is something like 18,000 rupees. So it is actually only an urban household that will be able to even afford it. And here also you think of whatever LPG, PNG, electricity you have as a backup. So that's the mindset that we have to actually move towards in all energy sectors. First choice, renewable. fossil fuels backup. So the same strategy we are talking about in rural and urban. So here, this is also stacking, but even the most polluting stove in the stack is still very, very low polluting, both from health perspective or climate perspective. And collectively, the stack will fulfill all your thermal energy requirements. So this is the strategy. Now here, a lot of work needs to happen. I have to say this, that there are very few trained scientists who are working in this sector. There is a huge amount of innovation that is possible if we get people who understand combustion chemistry and fluid dynamics in designing even better biomass stoves and also for solar devices. So there is a huge vacuum there where we need people. In the urban context, the problem is slightly different. Here we find that there are many people interested in using these technologies, but they find that their kitchens are not designed in a way that they can incorporate these devices in their kitchen. So here more innovation is needed on the architectural side. I often give this example that when washing machines first came into India, there was no space in the house to put the washing machine. But now you look at any design of any new construction, there is a space for washing machine. Same thing needs to happen for the urban biogas system. We have to design kitchens which come equipped with the architectural requirements, so that if people are interested, they can install a biogas system. So that is where the innovation needs to happen here. We have worked mainly in the rural context with a different approach based on our capacity. When I realized that just looking at efficiency and emissions, I am designing stores which nobody wants to use. Then I went around, a bunch of us, we got some funding and we conducted workshops across India. And we identified 18 parameters that people value in their cooking energy device. Energy efficiency and emissions are just two of those, but there are many other things. Now, everywhere, not all parameters are not equally important. So we developed a methodology by which we first, we are generally invited as technical consultants by maybe a local NGO or a funder to work in a particular community. So first we understand what is the cooking energy system that is prevailing there. We have developed a gamified process by which we collect data on which 3-4 parameters out of these 18 are non-negotiable, are crucially important for that community. That women will simply not use a stove if it doesn't have those features. Once we identify those features, we then look for technology which fulfills those requirements and which is also efficient and low emission, etc. And those are the technologies that we introduce in that community. And typically we have found in the cooking energy sector till recently, if you went into a village, distributed some improved cooking energy devices, came away, went back 2 years later, you found 10% people are still using those devices, it was considered as a success. With this intervention, we are finding that 60 to 80% people continue to use those devices because the devices have been selected by taking their opinion and taking their needs into account. So this has been our contribution for the rural energy segment. For urban cooking energy, we are conducting these events, which we call Cooking for Climate, which are essentially experiential events. This is a joint activity of Urja Box, Samuchit Envirotech, and Vayu, which is the biogas manufacturing company, biogas plant manufacturing. We do these events where we invite, it's typically a group of 10 to 20 people, they pay to participate. Food is being cooked around them where we discuss all of these issues and then everybody eats and enjoys the food. So it's a fun event, but it gives people a flavor of cooking with these devices, and also confidence that you can include some of these devices in your day-to-day cooking. So that has been our intervention in the urban area. And there is something new which will be happening very soon. We will be inaugurating an innovation hub, which is funded by Cleaner Cooking Coalition. The first such hub in India will be coming up in Pune. And we are in fact looking for volunteer researchers for this. The strategy here is that research will happen in a participatory manner. So the cooks will be involved in the process, and the focus will be not just on laboratory research, but also working with the people in the field to come up with cooking energy designs which meet their requirements and which also meet the health and climate requirements. And we want to be technology neutral. As I said, it has to be a stack with different technologies that will fulfill all the needs. And therefore, what is happening today is people who work in solar energy don't know anything about biomass energy. And those who work in biomass energy have no clue what is going on in solar energy. That is useless, because we are putting together a solar cook stove, a biomass cook stove, and maybe an LPG stove also, and all three of them have to work hand in harmony to fulfill all the needs of the user. So we are looking more for multidisciplinary approaches here, and therefore the research will focus on solving the problem rather than developing a technology and promoting it. So that's a different mindset there. And the focus will be on this outcome that fulfill all user needs, ensure that users' health is not impacted, and ensure that climate is not impacted. There is a third category of kitchens. I mean, if the social angle of this is not interesting enough, there is an economic angle. Commercial kitchens. There is this huge boom of food cooked on wood that hotels are selling, and people are willing to pay excess money for that. Traditional food cooked in traditional ways. But that in fact exposes the cooks, which also happen to be women in most cases, exposes these cooks to even higher levels of pollution. And these fuels have to be purchased. So for the hotel owner, there is an incentive to go for a more efficient stove. There is a direct economic saving, and people are willing to pay for that. So this can be a lucrative business opportunity, that can we create carbon neutral kitchens for commercial establishments or even institutional kitchens, midday meal kitchens, and ashram school kitchens, and so on. So this is also another area where a lot of work is needed on technology development to meet the specific needs that are there for mass scale cooking. This is an idea that we are there for pushing for. We still haven't got funding for it, but we want to set up this type of a food stall, which will be run by either an urban or rural self-help group or youth group, where it will not only sell food, but it will also act as a demonstration facility or experience facility, where people can come and see how the cooking is happening, try their hand at various things, and so on. So this we call Urja Ksham, which is energy enabled, and we want to set up these type of hubs to promote this idea of commercial kitchens which are carbon neutral. So this is also one type of fuel stacking, which we are increasingly seeing now as the LPG prices are going up. But this is definitely not what is desirable. But this really, I mean, it shows some way of out of the box thinking that is happening at the user level. So point is, cooking can be healthy, climate friendly, and meet all the requirements that the users have. We just need out of the box thinking, which is centered on the user and is sensitive to their cultural concerns. Going back to the example I gave, the way a cook stove is designed, we just boil a bit of water. But many people want to make rotis. We are not even testing these stoves for making rotis. Many research labs where some stove design work happens, they don't have kitchens. So user-centric, somewhere it is missing. As scientists, we seem to be approaching this thinking that these poor, helpless women need our help or something like that. Somewhere we have to give up that attitude and work with the user to develop solutions. So finally, this is a pledge that we have made at Cleaner Cooking Coalition. We want to have cleaner and affordable cooking energy for all by 2030. And by 2050, the entire cooking energy sector has to go carbon neutral. That means no LPG cooking and so on. So this word cleaner refers to cleaner than the traditional. Because currently the tendency is to push for the cleanest, but nobody is willing to use the cleanest 100% of the time. And therefore the health benefit is not being delivered anyway. So let us go for something which is cleaner than the traditional, but it meets the user needs and it meets the health and climate agenda also. That is the philosophy behind this name, Cleaner Cooking Coalition. So I hope that I have given you some different perspective of looking at the cooking process happening in your own kitchens and the kitchens around you. And if any of you are interested in exploring this field more, exploring what are the possibilities where inputs are needed, you can definitely get in touch with me. Please take a look at these 3 websites. I am sort of unable to remove this bar, but it is samuchit.com, urjabox.com, and cleanercooking.org. So take a look at these websites. You will find a few position papers on cleanercooking.org, which sort of elaborate on this overall philosophy that I have talked about today. So thank you very much. I'm happy to answer questions.
Thank you, Dr. Karve, for really a very, very nice talk and for explaining the logic and science behind it and also sketching out all the challenges and opportunities. And as you said, that really the pledge was very enterprising, and I'm sure many of us would like to join in that idea. And really, we hope that some of these people can see the challenges and do join them. And it's also a good thing to see the applications of the science to the wider fields. So, yeah, questions. Please raise your hand so that I can pass around the mic.
Thank you. That was an excellent talk and very practical, I would say. So my question is, so your organization is one, and how many such other organizations are there in India?
Very few. Actually, very few. There are several, let me put it this way, there are several people who are selling biogas plants. There are several people who are selling solar cooking energy devices, several people who sell improved cook stoves. But the kind of technology neutral approach that we have taken, and we don't sell any product, but we sell knowledge. So that I at least don't know of anybody else who does that in India or even outside.
Ask a follow-up question. Yeah, so that's what I guessed. But also what I see is that there is not much state involvement in coming up with a policy which would enable this.
Yeah, true.
Because you have some ideas and you are waiting for funds. The thrust should be from the state to enable these. And I think that is a big lacuna in this area.
Yeah, that's true. We have been, I mean, all the decentralized renewable energy people, we all came together and created an organization some years back called Clean Energy Access Network. And that is our sort of the face which interacts or tries to interact and influence policy. The pushback that we have been consistently getting over the last few years is that the government is fully behind LPG connections for everyone, which is a very good agenda, I must say, because that creates a possibility for people to cook on a healthier fuel. And now the focus is shifting to electricity. The argument is that there have been years programs have run to promote improved cookstoves, promote biogas plants, and they have not really made much of an impact. But the reason why they haven't made impact is because it has never really been user-centric, and all the requirements are not being fulfilled, etc. So without understanding that, it is said that, look, so many people have shifted to LPG and electricity, so now rural people will also shift there. But it is not realized that the shift to LPG and electricity was part of a bigger shift in lifestyle. So there is some lack of understanding of the social, cultural aspect around it. And therefore, there is no government funding for these initiatives. But we feel that because of the insistence that only LPG and electricity will be supported, people are getting trapped in cooking on polluting devices, because if they cannot afford LPG, that's the only option they have. No other options exist for them to shift to. So that is what we see happening, but somehow we are not making a dent, not able to make a dent in policy.
So I liked your sentence that we are not selling the product, the knowledge. And I think that's also the really a uniqueness of your effort. And we are indeed fortunate to have this from all this information from you about it. Yeah. So questions. We'll of course go to the questions from Zoom, but I think some of you should feel bold enough. Don't hesitate.
I think you have a question or a comment. Felt like you want to say something.
Of course, we can come to Anish, but anybody else?
Ma'am, can you please say a bit more about a cleaner cooking coalition? Like you said that you would be saying a bit more about the.
Yeah, so I explained where the name came from, the Cleaner Cooking Coalition. It's a international group where we have partners. I'm working here in Asia. There is a person working in Africa and a person working in South America. So we are all working at the field level and getting frustrated with this overall push for LPG electricity without looking at all these renewable energy options. So we came together and decided that we want to lobby for the cleaner cooking as against cleanest cooking. And that is how we have started. It's a small, I mean, there are just 4 of us actually. But we have managed to do some good work in Africa, actually, in Malawi. My colleague who is working there, they have managed to get the local, the country government on board and promoting these smokeless cook stoves is part of their own climate change, the commitment under Paris Agreement to address climate change. So it has become a national program there. But in other places, we are still struggling to get governments on board.
Yeah. So you have this very practical way of going to cleaner cooking, and then by 2050, you said one should be carbon neutral. So what is that final shift? Is it to solar, or is it to solar and electric? I mean, solar is also electric, but so what's the target?
So those are the clean stacks that I talked about. So it will be a combination of biomass, solar, with fossil fuels as backup at the
So,
most.
so even in
So-
2050, I mean, your national target also has fossil fuel as backup? That's
Not necessarily. Because particularly electricity with improvements in battery technology, solar PV system with battery storage capacity can address some of the issues around renewables of intermittency and other things. So we may not need fossil fuel backup at that point in time.
Yeah, because if you look at like, for example, in Europe or US
Yeah,
now,
yeah.
they have almost completely switched to electric, right?
Yes, exactly.
So, and that seems to work because there is a very strong
Yeah.
electric grid
Yeah.
backup behind it.
Yeah.
So you don't need to go to anything else.
Yeah. That is true. There are also cultural issues, and even in Europe and US, they still have barbecues. I mean, so so people will use a variety of fuels. So we have to give them renewable options. That's the main thing.
Okay. Yeah, so maybe we can take from Zoom and then in the meantime, if somebody has it.
Okay, questions from Zoom. Subatole, yeah, Subha, you want to ask questions? Please unmute.
Yes, yes. So thank you. Really thought-provoking
Can't hear.
talk.
Yes.
Oh, I unmuted myself.
No, there's some sound issue.
We can't hear, just wait a minute.
Yeah, the volume is too low.
Okay, is it better now?
Shubha, we can't hear you, so
Yeah,
please
okay.
wait.
Can you ask that to me?
Can you repeat the question?
Just for testing.
Is it better now? Can you hear me?
Yes, better.
Yeah.
I'm going to try and switch my microphone just in case.
No, I don't think the problem is on her side. It's the sound.
Okay.
on this side.
Sure.
Is it, can you hear me?
Yes, yes. Please go ahead.
Okay, all right. So very thought-provoking talk. Thank you. I'm sure you've received many accolades, but I guess it's not possible to not be completely impressed with your work.
Thank you.
Especially the attention to the actual user. I mean, that perspective is important. My question is about the detailed benefits of the traditional stove. I understand that how you brought out that the traditional stoves have multiple uses that the standard LPG one doesn't. But most of India is kind of warm, or at least when the cooking is done, it's fairly hot. I mean, at night, things get cold. But why would the continuous heat coming out of a traditional stove be beneficial? The other angle is multiple uses. Yes, you heat water and this and that, but for that, you're burning fuel. So, is it possible that the traditional fuels are cheaper or free? You gather wood, the last picture you closed on with a log of wood resting on a LPG. The fact that it's free may have more to do with it than the versatility of the stove. I mean, I'm trying to understand. So to my mind, just from my instinct, because my native place had these stoves and I used to observe the residual energy from the coals being used for many things. So apart from that slow heating benefit and continued warmth benefit, I'm not appreciating the rest of the benefits.
Yeah, true. So the space heating part is valid, of course, only in the cold regions, or in the winter season in some other parts of the country. But the slow heating as a food preservation strategy is what in most places women are using. Like milk, for example, you can just keep milk on the stove and it will preserve if you don't have a refrigerator, especially because of the hot climate. Also, another thing which we noticed in many places is night time after the dinner is cooked, the lady will put a vessel with water on the stove and then in the morning you have warm water to wash your face and hands. So there are a variety of ways in which people are putting it to use. But what you are saying is also true. Affordability is very much a concern, and you just go out and collect firewood, or it comes from your agricultural farm, and that fuel is free, is a big consideration for many people. We have in fact also seen that suddenly there are pockets where people started saying that induction stoves are becoming popular. And when we explored, we found that those are the pockets where nobody pays for electricity. So in other areas, if you try to sell induction stoves, there were no takers. But at the same time, I can also tell you that there are, if especially in Western Maharashtra, if you go to villages, there are households which now own LPG connections for 20, 25 years. They have taken those connections on their own without any government program running for them or anything. But at the same time, a traditional stove is also operating in those kitchens. And when we talk to people, we realize that making bhakri, for that, they use the traditional stove, and the sabji that goes with it, that they make on the LPG stove. And we also typically find that it's not very easy to make bhakri, especially the large one, on an LPG stove. So as I was saying earlier, this transition to 100% LPG is not a sort of a singular transition. A lot of other things have changed. So we in urban areas stopped eating bhakri and shifted to wheat rotis, which also happened sort of simultaneously. And so that there are these type of cultural aspects also which are keeping people using these traditional stoves. So there are certain functions for which they feel that they have no other option, and therefore, even though they have other cook stoves, they will not 100% shift. And data shows that even if you have 15-20 minutes of a traditional stove operating in the kitchen, that will negate all the benefits of maybe 1 hour of operation of an LPG stove because of the air pollution. So the main point here is that just spreading LPG is not solving the problem. As long as traditional stove is in operation, there will be a health issue. So if we want to find a substitute for traditional stoves, then we have to figure out in that stack, what is the function that now the traditional stove is performing, and can we replace that with something else? So that's the way we have been thinking. But yes, I totally agree with you that cost is a big factor. And in fact, it's actually tragic. I mean, we have this below poverty level households which got their first cylinder free. For a couple of months, they experienced smokeless cooking, and now they cannot afford to buy their second cylinder and are going back to cooking on traditional stove, which is even worse. So that is why we need all the other options also.
Yes, yes. I grew up eating those bhakris, so I know. Yeah.
There's a question. Arnav, do you want to unmute and ask question? Okay. So the question is, the trash flasher charcoal making system seems to be something that is scalable. Is it not possible to use the heat from the burning volatiles to, say, heat water for domestic / industrial use, in brackets, say, large canteen?
Yeah. So the trash crusher was specifically designed for urban garden waste management. So we needed to keep it small, portable. It's actually entirely dismantleable. These are just panels which are screwed together. So the packing is actually pretty thin. You just join the panels and make that trash flasher, use it during particularly winter season when a lot of trees are shedding leaves and even your compost pit is not able to handle that. That is when people will use this to convert the garden waste into char. And char is not just a fuel, but you can just put it back into the soil and it will improve the soil quality. So there are many other uses of the char made from this waste biomass. So this was designed specifically as an urban garden waste management solution because in Pune city, the municipal corporation declared that they will not collect garden waste and everybody has to take care of their own garden waste themselves. And open burning is also not allowed. There is a fine for that. So people needed a solution because composting is slow and not enough space, etc. So that is how we designed this. But now we have actually made a scaled up version of this, which is more for dealing with agricultural waste, which is in much larger quantities. The reason trash flasher heat, that heat of the flame cannot be used because this is a batch process. You fill it with trash, light the fire. Within 20 minutes, it becomes char. So you lift, the kiln is open at the bottom. So you lift it and then there is that heap on which you sprinkle water to douse the fire. So you can't keep on lifting your cooking vessel or whatever you are heating all the time because every 15-20 minutes a new batch has to be started. So it was not considered very practical in this case. But yes, with a larger system which will keep on running for an hour or so, and we are not going to lift it, we are going to open a door and get the char to fall down, etc. So there are now ways to make use of the heat of this flame, and we will we are in fact planning to work on that.
Okay. Another question, this probably you have answered it, so therefore one LS Pune is saying how to get these stoves in Pune.
So come to my office, which is on Law College Road. You have my email address here. So drop me a line and I'll share more details.
Okay, this just a compliment, I must say. So Arna Bhattacharya again. Okay, thank you for the answer. Great talk and thanks for all your interventions and efforts.
Thank you.
I have a question, I think because when you're going to the villages, for example, and trying to look at it or try to suggest it, there must be a kind of a resistance, right? Anything, because people have this. So what is it in your experience works best? Or what is it something which is like in some unique experience?
So when we started doing this process of first collecting information about what people are currently doing and what are their what features they want, etc., etc. So we found that having that conversation first before we go in with any kind of an offer changes the mindset of the people also. Because once we have those conversations with the community, they are more positively inclined because they feel that their opinion counts. It has been taken into account in bringing these products to them. So they are more open to trying out these new devices. So that's a sort of an unintended but positive outcome that we found, that just talking to people before offering them solutions is the one thing which creates a better environment for introducing new things.
But does it happen like, say, women who have to deal with this situation or this stove, they are more inclined to take something new, but the other members or the senior members in the family are not supportive?
Yes and no, in the sense that it works in strange ways. In some places, we have found that the men are very much interested in buying a new gadget, whereas the women feel that this is just going to add to their work burden. So that is also something that we come across. There is a generational tussle also that happens, that the younger women are more interested in trying out new things, the older women are not so inclined. That also happens. We are generally now with these projects working with somebody who has been working with the community for a long time. So it's typically an NGO working in an area. They invite us to work with them. So they generally know those triggers and how to handle those. So that also makes our work easy.
Okay, thanks. Any questions? Nishan, you have a question? Okay. All right. So thank you very much for really a very, very excellent talk. And we hope also look forward to more things from Samuchit. And we hope in some way we will also stay connected with it. And for all of you, she is going to be around in the evening and you'll meet her at dinner. So please do use the opportunity to ask her questions, which you probably felt hesitant to ask in the open day. So let's give her a big hand again and welcome, please.
Thank you. Thank you very much.
And